Okay, welcome to lesson 0.3, modules and blocks. There's lots to learn in this module, and I've broken the lesson into 3 parts with work for you to do for each section. So we're going to be learning to use arithmetic operators and BEDMAS. We're going to work with for loops, some conversion functions, and some functions from the random and math modules. And we're also going to work on learning to indent and organize our code properly. So let's begin by looking at conversions of data types. So now often when we're programming, we have to convert one data type to another before we can use it properly in a function. So we're going to start with a problem and just investigate the problem. Now I've created this file 0.3 examples.py. And I'm just going to type out all of the examples here for this lesson 0.3. And you should do the same so that you have a record of what you learned on this lesson. And you can also be putting your solutions to the various lessons right here in this folder, right? So when you do 0.2a, hello world, you can put it there and so forth. And so everything will be together for unit 0. Okay, so let's begin by typing out the program over here as shown. So A equals cat, the string, B equals 7, the integer. Now we'll type print A, print B, and print A plus B. Okay. So, let's now try to run this program. Okay, and so what you can notice down here in the terminal is that cat showed up and 7 showed up. So in other words, this program was able to execute all of these lines, print A, print B, but then as soon as we got here, print A, B caused an exception, and an exception is an error, and this one was a type error. And we get this message can only concatenate str, not int, or string, not int, to string. In other words, this is saying you can only join a string with a string. And that should make sense because if you look at this, really, print is expecting strings, but what we did is we gave it a string plus an int, 7. So if the goal here really was to concatenate cat and 7, so that just said cat 7, then what we need to do is take this integer b, okay, and convert it using the str function. So we can add str, open bracket, and then add a close bracket, making sure that we have our second close bracket, the one that closes the first bracket here. And then so now let's look at this. Now we have a plus strb. Now let's run this again. We'll press stop and we'll press F5. And now you can see the program worked, right? We saw our cat, it printed A, printed B, and then it printed A plus the string version of B. So let's add a quick comment here before we go to the next example, just showing what we learned. So this was converting an integer to a string. Or, in fact, you could use that to convert a float to a string. So if B was 7.0, that would work just as well too, right? Converting, really we should say converting to a string. Okay? Another problem that happens sometimes is the following. So let's type this program. And it's kind of hard to see this in this video, but you should be able to pull this up on Edsby separately or just follow along as I type here. So the first line is my num equals, we're just going to type input, okay, and use the input function. So we're going to take a number there, and double my num is equal to 2 times my num, okay. And then what we're going to do is just print double your number is, and we'll here now use our str function to put double my num. And you notice how the program automatically found the variable we used, so I was able to just press enter to automatically fill that in. It's a nice feature of VS Code. Okay, so what the point of this program is to take a number, take an input from the user, double that number, and then print it. Now, before we run this, what I want to do is just comment out all of this. Remember that you can select it all and press Control/ to add comments to them all. Then when we run this, we're only going to see any output from this. Okay, so let's press F5. Okay, and so actually the program is now waiting, the terminal is now waiting for our input. So we can type a number like 5 and press enter. Now do you notice what happened here? It said double your number is 55. Now that's curious. So what's going on here? Well, what's going on is we have a data type problem for which we'll need some conversion. Now, VS Code is smart enough to actually figure out what kind of data type a variable should contain. So if you just hover your mouse pointer over my num, you'll notice that it says str. So it's showing that the data type is str. And the reason for that is because on the previous line here, when we assigned my num to input, input actually takes text from the user and returns it as a string. As you can see here from the output, right? Read a string from standard input. So no matter what we type in here, okay, my num contains a string. And if we want to actually double the number that's entered, what we need to just do is convert this string to an integer or a float. But for now, let's use the integer conversion. int, open bracket, close. So now when we run this program, press F5. We'll enter a number, 6. W number is 12. Now we also could have actually just converted this input and stored it in mynum as an integer immediately. So if we typed int up here and then put the input function inside as an argument, then we would already have an integer by the time we get to this line. So this should also work just fine for. And one last one that we should look at is the float conversion function. So let's just fire up the terminal for this. Type Python. So if we type float and then put an integer inside, okay, you can see that we have the float version 3.0. We can also convert a string version of a number like 15. So you can type 15 in quotes and we get 15.0. So that's it for conversions. Right now, pause the video, go to Replit and to section 0.3 and complete assignments A through C. Now that you're done those assignments, we're going to look at modules. So Python has this big list of standard functions called built-in functions. And you've seen these before, but here they are again. There's about 40 or 50 of these things. And we learn a fair amount of them. But all of these are contained within Python, the actual Python program by default. And so you can access them whenever you're programming without having to import them. Now, in contrast to that, modules are external programs full of more functions that do all sorts of useful things, but these are not accessible by default. So let's look at these really quickly. So here is the module index for Python. Now these are all modules that come with Python, but are not loaded by default. And each one of these contains its own set of functions. So if we click copy, you'll see you can scroll through and find different methods and functions that are part of the copy module. Here's one called functools, and you can see, right, that there are functions with their own descriptions here. So a couple of these that are really handy that we're going to use by default here are the math module and the random module. Now let's start with the math module. So let's say, for example, that we want to calculate the circumference of a circle of radius 150 centimeters. So one thing we could do is type this into the terminal, 3.14 times 150. And we get 471.0 centimeters. But the problem is that that's not very accurate, because we know that pi is actually a non-terminating irrational number. But we're lucky because the math module has a nice accurate version of pi. Let's have a quick look at this math module. So if we open this, this is the math module. It has functions, a whole pile of functions that are handy, and they're all listed here. Now, if we scroll down here, what we should be able to find is one that has pi right there under the constants. So there's one for pi and for e, and for a few others. But pi is the mathematical constant, 3.141592, ... and it goes on forever. So math.pi. Now, how do we actually access this? Well, the way we do it is by importing math. So let's just work in the terminal here. And what we'll do is type import math. And what that did there, just in that moment, is load all of the functions from math into the memory of the program, or in this case, the instance of the terminal. So now we can access any of the functions from math, any of these, that is, by typing math dot and then the function or the variable right after. So it looks like this. We can type math.pi. Now this is truncated, it's shortened, but this is showing us now quite a lot more accuracy. So we can type, now we can type math.pi times 150, and we get a little bit more accuracy, that is, some decimal places. Another useful function is the math.floor function, okay, looking like this. What this does is take a float argument x and return the closest integer below x. So for example, let's try a couple. If we type math.floor and we put the number 1.4 in there, we get 1 because 1 is the closest integer below 1.4. If we try 1.7, we get again 1 because 1 is the integer below 1.7. Next, let's try 2.9. What do you predict is going to happen here? Of course, we get 2 this time because now notice how this is not rounding, right? It's not rounding up to 3. It's kind of rounding it down to 2, right? So no matter what we type here, it's going to round to the lowest integer below that number. Now, of course, this is going to be -4, right? Because -4 is below -3.8. If we round math.pi, we get 3. So next we're going to look at the random module. So we'll start by importing random. Type import random into the terminal. And the random module contains functions that relate to the generation and organization of random numbers and objects. So one example is the randint function, which we can use to generate a random integer between its arguments x and y, inclusive. So this randint function has 2 arguments, and so we use a comma to separate them. So we're going to type it here. So random.randint, and we'll type 1, 10. And what this will do is give us a random integer between 1 and 10. Now, what you'll notice is when you type that, yours is probably different than mine, which is kind of cool. Everybody gets a new number. You can press the up arrow, and that will bring up the last line of code that you typed into the terminal. And then press enter again. And keep trying this. You'll notice every time you do this, you bring it up, you get a new integer. So let's say we wanted to generate a random integer between 1,000 and 2,000. Well, we could do that by just changing our arguments. So there are 3 main ways of accessing modules. The first is to do it the way that we've just been doing it, to import the module directly, optionally with an alias. And so this square brackets here that I've added mean that you can optionally add this. Now, I'm just going to read this through and then give you some examples later. So, because the functions in a module are defined externally, that's inside the module and not in our program, we have to reference them by typing the module name. This is what we did with math and with random. right? We type random and a dot random randint, which is the function inside the random module, or alias dot randint. So over here, what we could have done is named, we could have typed import random like this, import random as r. And what would that would do is basically store the random module in the variable r. So now instead of typing random.randint, we can type r.randint 1,5, and we again will get a random integer between 1 and 5. And that's really what an alias is. It just gives you a way to kind of short form or to abbreviate a module name, especially if it's long. Random's not so bad, but something like matplotlib, often that's abbreviated mplot. So now the thing is, when you use import module in your code, what you're doing is importing the entire library into your program, even though you're probably not going to use more than 1 or 2 functions from it. And when it comes time to compile your program into an executable file, the whole module, including all the parts of your program doesn't use, gets bundled in with it, which causes bloat in your file. And so for this reason, there is a way to import only the functions you need. So the next way of doing this is using the from keyword. So what we can do is we can type from module import object1 as alias optionally, object2 as alias optionally. So if we know we only need a particular function, like for example, we need just the randint function from random, we can type from random import randint as rand. So let's try that here. So from random import randint as rand. Now what this did is just import the randint function, and we added this alias as rand so that we could reference it by just typing rand. So now we can type rand 1,3, and we have a random integer, right, between 1 and 3. So if you know you're only going to use 1 function or 2 functions from a module, then use this version because it only imports that 1 or 2 functions that you need. Now the complete opposite of this is to use from module import star. Now what this does is literally import everything from a module or submodule as if they were defined internally in our program. And so, for example, if we were going to use a lot of functions from the math module, we could type this from math import star. And what that literally does is mean that every single function and every single constant in math we could reference just by typing it as if it was a variable we defined. So we could just type pi, okay? Or we could type cosine of 5, and we would get an answer, because that cosine function and that pi, normally we would have to type math.pi, right? Or math.cos5, but we imported it to the local namespace. I'm getting errors here because we didn't import the math module. We imported all the functions and constants from the math module. Now, the kind of the catch with this is that this is discouraged in general because references to externally defined functions and constants are not always clear. So if somebody else comes to read your code and starts seeing unexpected functions that they don't recognize, that you haven't defined in your code, they might not understand where they're from. And the second reason is that you end up with variable names you don't expect. So when we typed this from math import star, we actually now have all kinds of names of functions and variables that are reserved, which we could accidentally end up using. So you don't really even know, unless you've checked the whole module through closely, what you're going to be getting in your namespace. Now the best way to see this really is to see it using the visualizer. So just click this link here and open this in a new window, and it will look like this. So this is a very cool little program called a Python visualizer. And so what you can actually do here is type code in and then see what your code is doing. See all the stuff that's showing up in your code as you type. So we'll start by just typing import math, and we'll press enter. And as you type your lines of code and move throughout the code, it actually shows over here what is showing up in your program. And so typing import math, when that gets run, what happens is the math object, which is a module, gets loaded. So we have this variable math, and it points to a module instance, which in this case is the math module. So in order to actually access all the functions, we have to use this math variable and type math.py or whatever we want to do. So we can store math.py in the variable j. Okay, and you can see it there, right? So j contains the value pi. Now let's say we're going to use pi a lot in our program. Well, what we could do maybe is just import the constant pi. So let's delete this and type from math import pi. And now you can see what we got here is just one name, one variable containing the value pi. And we could then just go ahead and use this pi just like this by typing pi. And the last way of doing this is the most telling. So if we delete all this stuff and we type from math import star, what you'll notice is a bajillion things that just showed up in our namespace. So literally all of these things here are now variables that we can reference, right? So we can type the cosine of pi, right? And we can reference any of this stuff immediately in our code. And again, this is discouraged because we get all of this stuff in our namespace. And if we wanted to say, create the variable pow and set it equal to hello and press enter, well, guess what? There's already a pow in this list right there, and we just overwrote whatever it contained with the variable hello. So, or with the data, the string hello. And so in other words, we get unpredictable results and effects when we import everything from a module. So that's it for modules. Again, you can now return to Replit and complete assignments D and E and import some modules. When you're done, return here and we'll continue on with flow control. Hey, welcome back. So you may have noticed a few things change here. A few more notes showed up, and well, I added some comments to describe each of the examples that we did previously. Just kind of organizes things a little better, and makes it look nice so that you can remember what we did on this note. I also do this at the beginning of the next video, but that doesn't last super long. In any case, let's go now to flow control statements and learn about for loops, which is the main thrust or the main flow control statement that we're going to learn about. So a flow control statement is a line of code or a statement that changes how the execution in the program proceeds. So far everything we've done, right, every program we've done has basically executed every line one at a time. So it would start here, line 1, 2, 3, 4, 5, 6, and go in order, executing everything that you've written without any repeats or any loops of any sort. But the thing is that quite often when we're coding, we need the ability to repeat or skip parts of code under certain conditions. Okay? And so that's what flow control statements do. They give you that kind of control. So before we get to for loops, we're going to look at the range object. So a range object is just something that contains a bunch of numbers. Let's just look at this. Let's experiment. So go to your terminal here, and we'll type in a bunch of things. So we'll start by typing, and now each of these range objects, I've encased it in a list function so that we can see what's inside the range objects. We'll type list and then range 3. Right, so you can see here that range 3 contains the numbers 0, 1, and 2. Now if we just typed range 3, all we would see is this kind of cryptic version with this extra parameter in here. So this version with the list, right, just basically shows us the contents of the range 3 object. Okay, let's type the next one. That's range 5. So we'll type list range 5. So this time you can see that we get a list of numbers from 0 to 4, right? Let's type list range 20. And this time we get all the numbers from 0 to 19. So hopefully you're seeing a pattern here, right? Essentially, right, if you just put one number into a range object, it's going to give you all the numbers from 0 up into, but not including, the number that you specify. And that happens to actually be the number of objects that appear. So if you type range 3, then you're going to get 3 numbers, right? 0, 1, and 2. And range 5, right, had 5 numbers from 0 to 4, and so forth. So this is one way to kind of specify a number of things, a number of numbers, like a bunch of numbers in an object, in a range object, is to pick this number according to how many, okay, you want. So now let's say that we wanted to start at a number that was not 0. Okay, well, if we don't specify a start, then it's always going to start at 0, like it did with these ones. But what we can do is we can type a start value by putting something like range 1, 3. So this time, okay, we have start and stop. And the start actually comes first, right? So 1, this means let's start at 1 and then go up to 3, but don't include 3. So we get 1 and 2. Right, so if we do list range 4, 7, then we'll get the numbers 4, 5, 6, but not including 7. Right, so we get 3 numbers. Let's try list range 10, 20. And so here we get the numbers 10 through 19. Right. So this is nice if we want the list of numbers that we're going to use in our loop, okay, to start at a certain number and go through to another value, right? One less than this value always. Okay, let's try a few more here. Now, what if we add a third parameter? Well, let's try 0, 0, which is our start, 10, which is our stop, and then we'll type 2. And look, we got 0, 2, 4, 6, 8. So this parameter here, if we optionally include that, what this does is actually tell the range object whether or not we should skip any numbers, right? So this means count by 2, right? So we're going to skip every other number. Starting at 0, we're going to count by 2. So we go 0, but we skip 1, and we go up to 2, and then to 4, and to 6, and to 8. But we don't hit 10 because that's our stop value. Let's try another one of these. List range, let's see, 0, 20, 3. Right, so this time we start at 0 and we go up by 3 until we would hit 20 or anything above 20. Right, so we get 0 through 18. Let's try another one. This time we'll go list range. This is a little different now. 10, 0, -1. Now, try to predict what you think will happen with this. So this means start at 10, end at 0, with a step of -1. So if we press enter, okay, maybe you guessed this. We went from 10 all the way down, but not including 0, right? Because this time, the step value told us to go backwards. It told us to subtract 1 each time, right? Instead of go up by 1. Which is the default value that you get from leaving out this parameter entirely. Let's try one more. List range 100, 0, -5. Okay. And so this time, right, you can see we got the numbers from 100 to, and we went down by 5 all the way, but not including 0, right? All the way to 0, but not including 0. And so we went backwards in both of these cases because of the negative step. So just to sum up, right, a range object can contain up to 3 parameters. If you just include 1, that will mean the stop value, right? And it will go from 0 to that number. But if you include the start value first, then it will start with that number. But the default, of course, is 0 if you don't include it. And the step value, the step always, the default is 1. It goes up by 1. But if you include that, it will count by whatever you put in there. So next, let's look at blocks. All right, so multiple lines of code can be grouped together to form a block of code. And the Python interpreter recognizes a block by its indentation. Indentation means just adding spaces before a bunch of lines. Okay, and a block must be indented in Python, moved to the right, and each line must be moved at least as much as the first line of the block. Now, when you create a block by writing a statement like a for loop, VS Code will automatically indent for you on the next line. I just want to show you that over here. So if we typed for x in range 3 and then colon, you'll see that the next line starts indented, right? And my program here is saying, hey, where's my block? Right? Give me a block next. And then everything we type from here on in, print x, print hi. See, if we press enter, it's all going to be indented. And then once we're done with this block, we just press backspace and we continue on coding and doing whatever we want to do out here. Okay? And that would mean the block would be over. So the block ends as soon as you stop indenting, right? The block where you just were. So let's look at an example of a block, a big block, which I have here. This is a nice big one. So here in lines 12 to 26, right, there are actually is a big block here, which starts at line 13 and continues on to 24, right? And so all of this code right here from line 13 to 24 is part of the for block of the for loop that is going to take place. Now, even within that, there are some more blocks. And there's a couple if statements in here, which you'll learn about later, that each have their own little one-line block. So there's a block here on 18, and there's another little block 21, and there's a block here at 24. And of course, those end immediately, right? Those are one-line blocks. But that is completely reasonable. So here we have a great big block with 3 smaller blocks stacked inside. Okay, so what we can then do is come back here, and let's now look at for loops. So a for statement begins a loop, which is a section of code that repeats a fixed number of times, or until it's broken under a certain condition. Let's start with an example. Example 1. Use a for loop to print the numbers 0 through 9. Print one number for each line. Okay, so I've got the answer here, but let's look at it up right here. So let's type this, example 1, a basic for loop. And we will initiate a for loop by typing the keyword for. Next comes a variable. Okay, and you can put any variable that you want in here. And in this case, we'll just use the variable x, but you could use I or j or k or count or anything that you want. Then comes the keyword in. Okay, so we have to type in. And then finally, what we need to do here is include a range object, at least for this type of for loop. So a range object, as you already know, is going to contain a bunch of numbers, right? So what we've done here, what I've done here is created a range object with 10 in it, which you already know is going to contain the numbers 0 through 9, right? So there's actually 10 numbers. Now, inside this, we're going to create a block. So we'll type print x, press enter, and then we'll end the block. Okay. Now, in a nutshell, what happens with a for loop is whatever's inside the block will get repeated, okay, for each time there's a number in this range object. Okay? So as I've said here, again, the block that comes next after the for loop is repeated as many times as there are numbers, in this case, in range 10. Okay, which we already know there's going to be 10 numbers in there. right, from what we looked at before. And the second thing is that each time it repeats, x is changed to the next value in the range object. Okay? So, right, so if we have the numbers 0 through 9, x begins at 0 on the first iteration. And so when that print statement, okay, triggers for the very first time, it will be printing x, which is equal to 0. Okay? Then after that's done, the block comes to the end and it says, oh, but we have still got more numbers in range 10. So x will get the next value in range 10. It will get the value 1, right? And then the block executes again, right? So then we have print x, but now x is 1, right? So it prints 1. And then it goes back again and increments x to the next thing in range. In this case, it's going to keep going, right, all the way till we get to 9. Right? And this is the output we get, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because every time print runs, right, it's going to print everything on a new line. And the reason for that actually is because the print statement automatically adds like a return, like pressing enter kind of every time it prints. So it adds a special character which is called a carriage return, so that every time it prints, it's on a new line. And so that is a solution to example 1. So let's look at example 2. Example 2 says print the word hi in a horizontal line over and over again, separated by spaces. Oh, brother. Have the user input a number to determine how many times to print it. Okay, so we'll call this example 2 hi spam. And type this with me. So I've got the solution here, but I want you to think about this for a moment. Have a look here at what I've done. I've actually put an input, okay, converted to an integer right inside the range object. So let's type this. For k in range, int input. And we'll put a colon at the end. Don't forget your colon, right? Rookie mistake. It's always got to be there. And we'll type this next line. And then we'll talk about it. Print hi, and then we'll add this special keyword end equals space. Right, so just put a space in between single quotes, and we'll end the block. Okay, so here, right on line 21, what we're doing is starting a for loop. All right, and we're gonna run we're gonna run the number of times in range, whatever the user inputs here. So basically, as soon as the statement runs, okay, what's going to happen is the computer's going to get some input from us to determine what number goes in this range object. And that's only going to happen once, right at the beginning when the loop is initialized. Okay, and then k will take all the values in that range object. So it's kind of cool, right? Because you can stick an input function straight inside another function like this. And it converts it to an integer, and then that integer gets passed as the argument to the range object. Okay, then in the next line, what we do is we print hi, but I've specified something special here, and this is a keyword you can use as an argument, okay, to the print function. So we've said end equals space. Now what this does is it overrides the new line character that I talked about up here, right? So every time print does its job, it always prints an enter at the end of every line, but this says no thank you. I actually want a space instead of an enter at the end of my line. Okay, so every time this prints, it's going to print hi and a space. And then when it prints next, it's going to, on the same line, print another hi and a space, right? So this is going to happen the number of times that we run this, or this loop, which depends on what's in our range object. Notice how we're actually not using k, right? All we're really doing, right, is using k to help us, right, count through all of these range objects so we do it the right number of times. But we don't actually see k in here. So you don't actually have to use this variable in your loop if you don't want to. You only have to use it if you actually want to print what's inside the range object or work with the numbers that are inside the range object. So let's execute this. And of course, in order to do this, we need to comment out all this other stuff, Control/, and we'll press F5. And now we have to type a number, right? That's the first thing it does. We'll type 4. And we see high, high, high. Let's run it again. And this time we'll type 15. Right? And this time we get 15 highs. Wonderful. You know, you could run it again yourself and do it 1,000 times if you want, and it should work. Okay. Just before we move on from the for loops, I've also posted a link to Sal Khan's explanation of for loops, which will take you through everything nice and slow. He's very good at, you know, articulating an idea. He talks about range objects and for loops, and feel free to use that as a second explanation if you need some more explaining. So I just want to end this video with one last idea, and that's using two loops, one inside another, and this is called a nested loop. So nested loops are repetition blocks inside other repetition blocks, okay? And these can be used to achieve some pretty cool effects. Now, when you nest one loop inside another, it is like repeating something that itself repeats something. I'll say that again. When you nest one loop inside another, it's like repeating something that itself repeats something, right? So if we look here at this block that I've created, this is an example. We have this for block. And right, this big 4 lines, 18 to 21, they're going to repeat 5 times because of this range object, right? But every time, each of the 5 times this repeats, there's also another loop inside, right? This one's going to execute 4 times, okay, for each of these 5 times up here, right? So the total number of times that this little block is going to execute is going to be 4 times 5, or 20 times. Now this actually produces a cool effect. What I want you to do here is just cut and paste this. And we'll call this nested loops. And paste. And it looks like our indentation didn't copy over, so we'll just indent that, right? And then indent that one to keep things all proper. Let's comment out this. And let's run this program. And we'll kind of see something. All right, so there we go. So we have this little ladder with 5 rungs that I've created. Now, the best way to understand this, I think, is to use the visualizer, right? The visualizer. So let's click here. And if you click there, you should come to this place where I've already got this code pasted and ready to go. So what we can do now is we can click forward here to actually step through this program and understand what's happening to the execution to the program as we go through the loops. So if we click forward, it'll set I to 0, the first thing in range 5. Next, it's going to print something on line 3, and we'll see that show up here. Notice how we have an end statement of nothing. That means that the next thing that's going to be printed is going to be right beside that, right? Because there's no gap and there's no return. Here, now we're going to start the J loop, right? We're going to make J go from 0 to 3. And so this is going to happen, right, 3 times. So we'll click forward, right? And we're going to print a dash, right? So you're going to see a dash show up there, right? So there's a dash now. And of course, it's going to do it again because now J is 1, right? Now J is 2. And all this whole time, I is still 0, right? Because we haven't finished the block, right? That was initiated on line 2 from this for statement, right? So we're still going through the first iteration of I. I has not yet changed. So we'll just keep clicking this here. I is 3. Finally, I is 3. And now, right, we've run out of numbers in our range object. So it's going to continue on and we get to line 6. And it's going to print the little right side of the ladder like that. There we go. And finally, our block is done. Now we go back to line 2, right? So now this whole block's going to run again, right? So we click forward. And now we're going to get our left rung. And now we're going to get all the middle rungs. We're going to get 4 of them. Right, here we go. 2, 3, and 4. And then our right side, right? And this whole time, I was 1. because that was the second object in the range. Now this is the third one, so this is like the third rung, right? So we're going to click through this a little faster, and you can see each time we're going to get, right, we're going to get all these middle sections and then one of these at the end. Go back here, and this is the second last time this is going to run. And I just want to show you. So here we go. Now finally, I is 4, and this is the last, right? The last I in range 5. So we'll get our left side, right? And then now we'll get all our rungs in the middle, right? And there we go. And finally, we'll get our closing. And by the way, there's no end keyword here because we want a new line after this part, right? This is like the last, very last thing. So we click forward. It goes back to check if there's any more numbers in here. And of course, there's not. And so the program terminates. Okay, and so that's a really nice way of just of visualizing what happens. And if you're ever not sure of what's going on in your program, it's always a great. This is always a really great resource because you can paste your code in. If you just go to pythontutor.com, you can paste your code in there, click visualize, and you can step through it like this to see what's going on. So that concludes the video lesson for 0.3 modules and blocks. To practice for loops, now you can go to Replit and check out lessons 0.3, or rather assignments 0.3 F through I. Good luck with those, and we'll see you on the Flippity.